Hi guys. Today we're going to talk about a really important topic in object-oriented programming. It's called the class. All right, let's get started. So I've started here a basic console app in .NET Core, which is just a hello world as it comes out of the box, right? So first thing we want to do is create a class, which is separate from this class. And we'll make it, we'll come to our project here, right-click, add. You do new item or class, it takes you to the same thing. We'll call it animal. Just for simplicity, we'll do animals, dogs and cats for this example. All right. So right out of the box, it's not explicitly stating whether it's public or private, so we'll make it public so it can be accessible outside of this scope. And we will just leave it like this for a moment. Let's put a method in here. Public void with no return type. We'll call it make animal sound. How's that? And it won't take any parameters, and we'll just have a simple console.writeLine to print to the screen. Grumble. Okay, so make animal sound is the name of the method. Animal is the name of the class, and it's public. So if I was to come to my application and I say animal dot make animal sound, it should give me an error. And the reason for that is this is not instantiated. Instantiate means create an object of the type of that class so that you can access it and store things in its memory scope and that kind of thing. However, before we get into that, I want to show you something. If you were to change this to be static, then you would not need to instantiate it, and you could do it just like this. So let's rename this method. Right-click, rename, to make animal sound static. Because I'm going to hit F12 to go to that location. I want to also make another animal sound that does require instantiation. So we'll take off the word static there, and we'll make this a grumble grumble. And we'll take static off of here. It should give us the error again. And it does. Okay. So what we'll want to do, let me show you what instantiation does. So instantiation creates an object which calls the constructor of that class, which we haven't defined a constructor, which is okay. It has kind of a secret default constructor that doesn't do a whole lot, just creates an object of this. So we'll do that first. So we'll say animal, my animal, or Chris animal equals new, which is the keyword for instantiating classes as objects. And now we can do Chris animal dot animal sound, and that's how you call those methods that are not static methods. And the static methods don't have access to the non-static properties. So I think next we should talk about properties. Then we'll talk about constructors again, because there's a lot more interesting stuff with constructors. So jumping right into it, let's create some properties. So if you type prop and press tab twice quickly, it kind of creates this shorthand, my property, and then it's public, as you could see. But what this really means is it's a short form for a property. The property is really supposed to be like this: private, private meaning outside of here you can't access it. Private, my prop one, yeah, my prop one, and let's make it say a string, and then we could have a public string, and let's make this slightly different, underscore, so we can tell them apart easily. And notice I'm using a capital letter for the publicly accessible property here, and a lowercase letter for the private. So that's just convention, by the way. So my prop1, and then we're going to do open braces, and we're going to do a get open braces and a set open braces. And in the get, we're going to say return my prop1. And you can actually put other code, other statements in here, like you could say my prop1 equals to ABC plus my prop1, but that's kind of outside the conventions. It's typically not done. People don't look for code in properties, and in fact, you could set the compiler. I'm sorry, not the compiler. You could set your IDE like Visual Studio to totally skip properties going inside the code lines of properties when you're stepping through code. So you want to put as little code in those blocks as possible, but you are allowed to do it. It will compile. So in here, I'm just going to do a standard set. So let's say my prop1 equals to value. And value is just like a keyword that whenever you do like my prop1 equals ABC, ABC is the value, and it gets assigned here in this statement. And now if you were to reference this private variable, my underscore my prop1, locally inside this class in one of these methods, which you can access it there, you just can't access it outside, it'll be reading from that, which was set via that, if that makes sense. Okay, so that's properties. Now, because this one's a public property, you'll notice that this one will be available out here. So I could do chrisAnimal dot my prop1 equal to ABC, but I cannot do chrisAnimal dot underscore my prop. It doesn't even show up on the IntelliSense here, as you can see. It would give me an error if I did my prop1. See? So we'll take that out. Okay, let's jump right into constructors now. So if I go into the animal class again, if you make a method, and you want to put constructor at the top of your other methods typically, if you make a public method without a return type, without even a void return type, just nothing there, this will become your default constructor here. And oftentimes assignment takes place in the default constructor. So we could say my prop1 is equal to I did not use the copy constructor, or I did not I did not assign values manually, let's just say. So now if I run this, take that out, and we do console.writeLine chrisAnimal dot my prop1 should show that was set in the constructor. I hit F5 to run it. Oh, and we need some sort of thing to wait on here. Console.readLine just to stop it from running. All right, I did not assign values manually. Do you see that on my output here? Okay. Press return. So let's jump back into the animal class, and we'll create a second constructor. I am going to do what's called overloading the constructor by building a second constructor. You can also overload methods, but let's start with the constructor. Public animal, and let's do string new prop or other prop. And now we could do my prop equal to other prop. And what's happening here is that this other prop is being passed in as a parameter, and it's being assigned to my prop, which is now available in this object, this instance of this object. If you have another, it won't be there. So let's say I had up here animal chrisAnimal2 equals new animal, and we do let's say we use the other constructor here. So by Visual Studio is a great IDE. Eclipse does this too for Java, but as you can see, 1 of 2, I could hit the down arrow and it shows me my other choice, 1 of 2, 2 of 2. We'll use this one. So string other prop will say hello Chris here. So now if I run it, I'm gonna hit F12 here. It's going to use this one for this one for for this object, but it'll still use this for the other object because it used the other constructor. So why don't we do chrisAnimal dot make sound, and we'll do chrisAnimal2 dot make sound right after it. As you can see, these objects maintain their own data. So this object holds on to the data that we assign whenever we use this object, and this object's data is separate from this. That's important to note. I'm going to hit F5, and there you go. I did not assign values manually, showed up. Let's see what happened here. And other prop was assigned hello Chris. chrisAnimal2 said make animal sound. Oh, grumble grumble. We actually want to make it do something more interesting. Let's have it do my prop 1. So now we have make animal sound, make animal sound. So one of them should print out I did not assign values manually, and the other one should print out hello Chris based on the 2 different constructors called. There you go. All right. So next I want to show inheritance. So let's go ahead and create another class. So add class. Let's create a class called dog. And let's say dog is an animal. In here, let's give it a method, a public non-static return. So we could, since everything else I've showed you is void, let's change it up. Let's do string get animal details, and let's have it return I am a dog. So this right here is inheritance. In some languages you can inherit from multiple classes. There's different inheritance structures. C#'s pretty straightforward, pretty easy. It inherits from animal. So we come in here and now let's create, I went to the wrong one. Let's go to program CS and let's erase some of this just to make things easier to look at and create a new dog. So dog, my dog equals new dog. And now we can do my dog dot, and you can see because we inherited from animal, we have the methods from animal such as make animal sound, but we also have available the methods from dog such as where is it? What did we call it? Get animal details, I think it was. So let's run that. Oh, now this returned a value. So this returned, remember, let's go to that. So this returned I am a dog. It doesn't print I am a dog. So what we can do is we can wrap this in a print statement. Console.writeLine around that. F5. I am a dog. Okay. Let's take this to the next level. So you can have, remember we did overloading on the constructor. Let's overload a method just to show you that as well. Public string get animal, let's just copy paste. But in this case, let's give it a parameter. Let's say integer 5. And let's have it do something different. I am a dog that is, integer 5, integer number of years old, say. I am a dog that is years old, and we're going to pass in this here. I think in older versions, let me see here. Let's do, I think it's string dot format. There's a lot of different ways of doing this. What I just did right here. In newer versions of C#, like this one, you could actually do this even fancier ways. But let's just do it this way. It's simple enough. There's no need to complicate things. So it's going to take this value and put it in here. Let's see. Going back to program. We're going to go ahead and choose the other method, 6, and run. I'm a dog that's 6 years old. There you go. Okay, so next, let's go ahead and we showed overload. Let's show override now. In order to override a method, what you're saying is, I want to go out to that parent class, and I want to instead use this other method. Because you could have a dog, a cat, a horse, and a sheep all in different classes that all inherit from animal. And what you might want to do in that kind of a situation is you might want to make animal an abstract class. Abstract classes define what the methods are, but they don't specify what the methods do. So in animal, I may just list out the methods and their return types, and then in dog, cat, and sheep, we can implement those methods. And it's kind of nice because the IDE can kind of tell you if you're missing elements as well. And this also can be done with something called an interface, but I think I don't want to show that in this video. I want to stick with just abstract. So let's go over there and let's make this a abstract class. And I'm going to delete out some of the stuff that we're not going to use. And let's go ahead and make this abstract. Abstract, make animal sound. Now, you don't need to do anything else to define that all the animal classes, all the classes that inherit from animal, will have this method. You do need to specify, whatever the return type is here. But that's about it. All right, so let's go back down to dog. And as you can see, it has an error. Dog does not implement inherited abstract member animal.make animal sound. And that is interesting because the IDE is so cool. You can just click implement class and you see what it did. It dropped this new method right here for us. And by default, it has a not implemented exception because we haven't finished with this method. So let's make it do something now. And you'll notice the keyword here is inserted override make animal sound. That means it's going to run this code, not something else that's in that parent class. Although abstract classes, none of them are usually inherited, have details. The details are here. So let's make it do something. Console.writeLine. I am making a dog sound. Bark. Okay, so let's go over to program. And here it is here. And just run it. I'm making a dog sound. Bark. Right there. Okay. Let's see if there's anything else I wanted to talk to you about today. I think that is about it. There's a lot more. I mean, classes is kind of the main structure for object-oriented programming. There's all kinds of other things around it. But we've showed you properties, static versus non-static, abstract versus non-abstract, inheritance. One thing you often hear is encapsulation. Properties is like the best way to explain that. Remember how we had public properties, and this is the the short form, but the long form also had private values, and those private values are not accessible outside. That is called encapsulation, in case anybody asks you. It's encapsulating the data for security purposes, and I guess that's it. So have a wonderful day. I'm sure I left out a few things just because class is such a broad topic. So if you have any questions, feel free to reach out, and we'll see you on the next video. Thank you.